Hello and welcome. My name is Robert, and in today's video, I'm going to continue using the Tryhackme platform, studying for the CompTIA Pentest Plus certification. I'm in the attacks and exploits, picking up Windows privilege escalation. This room is rated at about 60 minutes, medium difficulty, and this is a premium room, so you'll need a subscription to be able to do this room. And just to preface this video and let people know who are watching, I do not have the Pentest Plus certification yet. I'm doing all this learning myself, so I apologize that I'm not able to speak to a lot of the contents as an expert. More, I'm trying to just document my learning path, so I hope you enjoy. Moving on from that, there will be timestamps in the description to help you easily navigate around the video. All right, let's get started with task 1, introduction, and I'm going to go ahead and make this full screen to get started. During a penetration test, you will often have access to some Windows hosts with an unprivileged user. Unprivileged users will hold limited access, including their files and folders only, and have no means to perform administrative tasks on the host, preventing you from having complete control over your target. This room covers fundamental techniques that attackers can use to elevate privileges in Windows environments, allowing you to use any initial unprivileged foothold on a host to escalate to an administrator account where possible. If you want to brush up on your skills first, you can have a look through the Windows Fundamentals module or the Hacking Windows module. Answer the question below. Click to continue learnings just to recheck. And now moving on to task 2, Windows privilege escalation. Simply put, privilege escalation consists of using given access to a host with user A and leveraging it to gain access to user B by abusing a weakness in the target system. While we will usually want user B to have administrative rights, there might be situations where we'll need to escalate into other unprivileged accounts before actually getting administrative privileges. Gaining access to different accounts can be as simple as finding credentials in text files or spreadsheets left unsecured by some careless user, but that won't always be the case. Depending on the situation, we might need to abuse some of the following weaknesses: misconfigurations on Windows services or scheduled tasks, excessive privileges assigned to our account, vulnerable software, and missing Windows security patches. Before jumping into the actual techniques, let's take a look at the different account types on a Windows system. Windows users. Windows systems mainly have two kinds of users depending on their access levels. We can categorize a user in one of the following groups. Administrators. The users have the most privileges. They can change any system configuration parameter and access any file in the system. And then there's standard users. These users can access the computer, but only perform limited tasks. Typically, these users cannot make permanent or essential changes to the system and are limited to their files. Any user with administrative privileges will be part of the administrators group. On the other hand, standard users are part of the users group. In addition to that, you will usually hear about some special built-in accounts used by the operating system in the context of privilege escalation. System local system. An account used by the operating system to perform internal tasks. It has full access to all files and resources available on the host with even higher privileges than administrators. Local service. A default account used to run Windows services with minimum privileges. It will use anonymous connections over the network. And then there's network service. This is a default account used to run Windows services with minimum privileges. It will use the computer's credentials to authenticate through the network. These accounts are created and managed by Windows, and you won't be able to use them as other regular accounts. Still, in some situations, you may gain their privileges. Answer the questions below. Users that can change system configurations are part of the administrators group. It says it right here. So we're just going to copy that, Control C and Control V it in, do the check. The system account has more privileges than the administrator user, A or nay. And this says that it has even higher privilege than administrator. So we are going to go ahead and write A for that. Check. And move on to task 3, harvesting passwords from usual spots. The easiest way to gain access to another user is to gather credentials from a compromised machine. Such credentials could exist for many reasons, including a careless user leaving them around in plain text files, or even stored by some software like browsers or email clients. This task will present some known places to look for passwords on a Windows system. Before going into the task, remember to click the Start Machine button. So let's go ahead and do that now. And as my machine comes up, I'm going to go ahead and close the split view. In a previous video, I showed how I set up to connect RDP sessions from my host virtual machine into these Windows systems that Tryhackme gives you. And the reason that I want to use my own RDP session is because I feel that it's a more stable environment and I can copy and paste into it. So if you want to learn how I did that, that video will be in the description of this video. I'm going to go ahead and exit split screen view and continue reading. I will connect to that in just a moment. You will be using the same machine throughout tasks 3 to 5. If you are using the attack box, this is also a good moment to start it, as you'll be needing it for the following tasks. In case you prefer connecting to the target machine via RDP, you can use the following credentials. Okay, so this is where setting up the RDP client on my host is going to come in. I made myself some notes to be able to easily do this. And again, those notes are also documented in the video that I listed in the description. I'm going to hit F11 to get out of full screen and open up my terminal. I've also done videos on how to connect via VPN into Tryhackme's platform. I'll also list that video in the description if you want to learn how to do that. So I'm going to sudo OpenVPN and connect to my RDP client, or I'm going to connect to my VPN first. So now I've connected with my VPN into Tryhackme. I'm using Terminator's terminal emulator. So I'm going to use Control-Shift-E to open another window vertically next to this one. And then I'm just going to minimize that window. And then I'm going to do Control-Shift-E again to split these. And then Control-Shift-O to go ahead and split into, again, now another horizontal window. So I have 3 windows for taking notes and doing miscellaneous things. Let's go ahead and just make this full screen real quick. I'm going to CD into my documents. And I have a directory that I've set up for this lab. And if we ls, I've got some notes. I'm going to go ahead and cat out those notes. And this is how I'm going to connect to my RDP session. So I'm just going to copy this, throw it in here. And then I'll use this window on the left in case I need to do anything in the lab. But we're going to connect. I'm going to use this IP address. I'm going to copy it to my clipboard. Come back in to what I've pasted here. And as you can see, I've already got the password set up as well as the user account that they gave me. Again, I did a video on that, so if you need to watch it, just check the description. To get rid of the IP address here, Control-Shift-V to put in the updated IP for the lab. Make sure I don't have an extra space there. And I'm going to hit Enter. And this should connect me. All right, so for now, I'm going to minimize my terminal. I have my RDP session. I'm going to go ahead and minimize this window too. And let's try to align these next to each other for doing these labs. All right, I think that's a good looking setup. Credentials. Now that we're all set up, we can continue on. Unattended Windows installations. When installing Windows on a large number of hosts, administrators may use Windows Deployment Services, which allows for a single operating system image to be deployed to several hosts through the network. These kinds of installations are referred to as unattended installations as they don't require user interaction. Such installations require the use of an administrator account to perform the initial setup, which might end up being stored in the machine in the following locations. And then we've got these locations that we could investigate. As part of those files, you might encounter credentials, and that gives us an example of what they look like. PowerShell history. Whenever a user runs a command using PowerShell, it gets stored into a file that keeps a memory of past commands. This is useful for repeating commands you have used before quickly. If a user runs a command that includes a password directly as part of the PowerShell command line, it can later be retrieved by using the following command from a Cmd.exe prompt. I'm going to go ahead and grab this, Control-C, and now demonstrate why I used my RDP session. I'm going to go into here. Or let's just do search, command.exe, pull up the command prompt, and I'm going to use Control-V to throw that in, as you can see, and hit enter on it. And that's our output. I'm not sure if Tryhackme has fixed the way that their split screen view works, if you can copy and paste from it. But I do know in the past I couldn't, so that's why I've set myself up this way. Feel free to let me know in the comments if that has changed, but I find this to be easier for me. So there's our output, and it looks like we've got a user and a password right here. So I'm going to copy that, and just right-clicking when you highlight it, copies it. And I'm going to go back into my notes. And I'm going to go ahead and put that in here. And now I've got some notes that I'm starting to gather on this machine. Note, this command above will only work from Cmd.exe, as PowerShell won't recognize the %userprofiles% as an environment variable. To read the file from PowerShell, you'd have to replace %userprofiles% with this environment user profile, $ environment user profile. Okay. Saved Windows credentials. Windows allows us to use other users' credentials. This function also gives the option to save these credentials on the system. Command below will list saved credentials. So let's go ahead and run this now. Copy and then Control-V to throw it in, hit enter. And it looks like we get Mike Katz. I'm actually going to copy, I'm going to copy this whole thing. Ooh. So it's got my commands in it as well. I'm going to go back into my notes. I didn't save what I had, and I'm just going to do something like this. And then Control-Shift-V to throw those in. And it looks like I hit an extra key at the end there. Well, we got some notes going, and maybe I could even go up here and kind of add some breaks so I know where one command ended and the next one began. Do 3, and then, okay, let's keep moving on. Because next we have this other command we're going to run. Copy that now. While you can't see the actual passwords, if you notice any credentials worth trying, you can use them with the run as command and the /savecred option as seen below. So let's go ahead and run this. I don't think it's going to run the admin. It's going to prompt us for a password if I do that, but we do see right above we have this Mike Katz. So I'm going to throw those credentials in here and run this. Now when I trigger this, when I hit enter at the end of the command here, it's showing that it's going to run Cmd.exe. So that's going to bring up another window. Let's just run it and see. There we go. Okay, got it to run. And we've got our new prompt. And if I do, who am I? I think I can do that on Windows anyway. Yes, you can see that I'm now in a command shell as Mike Katz, or command prompt on Windows. IIS configuration. Internet Information Services, IIS, is the default web server on Windows installations. The configuration of websites on IIS is stored in a file called web.config and can store passwords for databases or configured authentication mechanisms. Depending on the installed version of IIS, we can find web.config in one of the following locations. Here is a quick way to find database connection strings on the file. So let's grab this. And I'm going to run it. I don't think I need to run it as Mike Katz. So I'm going to run it in this top window. And we get all of this output. So I'm going to grab it and save it without reading through it. And throw that in here. So we've got some more notes. Oh, so right here we've got ID of a database admin with a password. Retrieve credentials from software. PuTTY. PuTTY is an SSH client commonly found on Windows systems. Instead of having to specify a connection's parameters every single time, users can store sessions where the IP, user, and other configurations can be stored for later use. While PuTTY won't allow users to store their SSH passwords, it will store proxy configuration that include clear text authentication credentials. To retrieve the stored proxy credentials, you can search under the following registry key for proxy password with the following command. I'm going to go ahead and grab that. And now we're going to input that into here. And it looks like we get Tom Smith with CoolPass 2021. Let's go ahead and grab that. Sure, that's fine. Throw that into our notes. I forgot to separate my sections. Okay, that looks good. All right. Note, Simon Tatham is the creator of PuTTY, and his name is part of the path, not the username for which we are retrieving the password. The stored proxy username should also be visible after running the command above. Just as PuTTY stores credentials, any software that stores passwords, including browsers, email clients, FTP clients, SSH clients, VNC software, and others, will have methods to recover any password the user has saved. And actually, speaking about that, if you notice at the beginning of the video, I'm guilty of this. I stored the credentials in a notes file for the lab right here. Exactly what they're talking about here. Answer the questions below. A password for the Julia Jones user has been left in the PowerShell history. What is the password? So this was the first one that we did, I believe. Yeah, Julia Jones. And it's right here. I can grab it from here or from my notes. And just right-clicking using FreeRDP allows you to pick it up. And then Control-V, I can throw it in. A web server is running on the remote host. Find any interesting password on web.config files associated with IIS. What is the password? of the DB admin user. So it looks like my RDP session just crashed. However, I do have the notes here, so I should be able to grab it right from my notes. So they wanted the web config. We did see that password right here. I'm going to copy that, DB admin, and throw that in. Check it. And I'm going to try to reconnect to my RDP session. Unfortunately, this is a common thing with these Tryhackme labs, and even if I was using the split screen, or at least in my past experience, the split screens would crash as well. Again, I don't know if it's gotten better. But also why I like to keep notes as I move through these labs so that I have the information in case the lab crashes. I should be able to answer all these questions. So what happened to my other prompt? Okay, we just got to move that. Next question. There's a saved password on your Windows credentials. Using command key and run as, spawn a shell, Mike Cats, and retrieve the flag from the desktop. So that's this window here. We want to navigate to, I'm trying to think on Windows, it's been a while. And I think it's CD users from here. And I might need to dir this one. We're going to go into Mike Cats. And I think I could go right into desktop from there. Nope. Okay, let's go into Mike Cats. Oh, I spelled it with capitals. Let's just see. We'll run dir here. CD into the desktop. All right, there's our flag.txt. To read that, I believe we can do type flag text. There we go. So we've got our flag. And I'll just right click, grab it, throw it in, check. Next question. Retrieve the saved password stored in the saved putty session under your profile. What is the password for the tom.smith user or thom.smith user? And it is cool pass. We'll grab that, throw it in. And I can move on to task 4 now. Other quick wins. Privilege escalation is not always a challenge. Some misconfigurations can allow you to obtain higher privilege user access and, in some cases, even administrator access. It would help if you considered these to belong more to the realm of CTF events rather than scenarios you will encounter during real penetration testing engagements. However, if none of the previously mentioned methods work, you can always go back to these. Scheduled tasks. Looking into the scheduled tasks on the target system, you may see a scheduled task that either lost its binary or it's using a binary you can modify. Scheduled tasks can be listed from the command line using the sch task command without any options. To retrieve detailed information about any of the services, you can use the command like the following one. And we've got this, which maybe we want to try running that in here. I'm going to throw that in here, but I'm also going to just make a note of this because I didn't earlier. Throw that into my notes. Just to keep it updated. Now let's try running this command in here. And we get a list of all the scheduled tasks. Task user 1. Looks like exactly what we're looking at here. You will get lots of information about the tasks, but what matters for us is the tasks to run parameter, which indicates what gets escalated by the scheduled tasks, and the run as user parameter, which shows the user that will be used to execute the tasks. If our current user can modify or overwrite the task to run executable, we can control what gets executed by task user 1. So I think I want to run these as my cats, actually, not as the THN unpriv user. All right, to check the file permissions on the executable, we use ICACLS, or let's see, let's grab this command and throw it in, and throw it into this user here. Run it from here. Successfully process one file. Type text. So it's right here. We can see users IFF. Okay, so what is that telling us? As can be seen in the results, the built-in users group has full access over the task's binary. This means we can modify the .bat file and insert the payload we like. For your convenience, nc64.exe can be found on C drive tools. Let's change the bat file to spawn a reverse shell. Okay, so we're going to grab this, copy it. We can start a listener on the attacker machine. So I want to start this listener on my machine. I think I want to do that first. So netcat lvp 444. I'm going to throw that here. VP 4444. Run my netcat listener. Then in here, I want to throw in the command they gave us, echo C tools. I need to put in my IP address though, which unfortunately I have to kill the netcat listener, and I need to do IPA. And I'm looking for the ton0 address. I need this, copy that. Now I can run my netcat listener. Just remember, if you're doing this the way I am, you need ton0 because you are VPN'd into Tryhackme. And I need to replace the attacker IP with that. Okay, so that should work. I'm gonna hit enter, run it, see if I got a reverse shell. I did not. What did I do wrong? Oh, I didn't finish. Okay. This just wrote to the task, I believe. Now I need to run this down here. The next time the scheduled task runs, you should receive the reverse shell with task user 1 privileges. While you probably wouldn't be able to start the task in a real scenario and would have to wait for the scheduled task to trigger, we have provided your user with permission to start the task manually to save you time. Okay, you can use the run task. Let's grab this and run it. Makes sense. I was missing a step. So now we need to drop this in and hit enter. Success, it should have run. And you can see we've spawned a shell. Who am I? Task user 1. What directory? We don't want a dir system32. We're going to users, dir. Okay, we've got task user 1. You will receive the reverse shell with task user 1 privileges as expected. Yep. Okay. Go to user one's desktop to retrieve the flag. Just need to CD to the desktop. Need to CD first to task user one. CD to desktop, dir type flag.txt, and we're able to get that. Now I could go back and save the notes from how I spawned the shell, did the netcat listener and all that. I would encourage, if you are learning all of that, to grab notes on it. It does help you for later. But I'm just going to save the relevant information here. Grab that flag. Always install elevated. Windows installer files, also known as .msi files, are used to install applications on the system. They usually run the privilege level of the user that starts it. However, these can be configured to run with higher privileges from any user account, even unprivileged ones. This could potentially allow us to generate a malicious MSI file that would run with admin privileges. Note, the always installed elevated method won't work on this room's machines, and it's included as information only. So this is going to be just information only. This method requires 2 registry values to be set. You can query these from the command line using the commands below. So let's go ahead and just query them in our system as our elevated user. And for some reason, it is not pasting like I want it to. There we go. And we can see it's not recognized. It's just, oh, actually, did I do that right? No, I did that wrong. I grabbed the whole thing. Need to leave off the C drive from it. So let me try it again. Okay, so the system was unable to find the specified. And yeah, it's going to say it for the same one. To be able to exploit this vulnerability, both should be set. Otherwise, exploitation will not be possible. If these are set, you can generate a malicious.msi file using msfvenom as seen below. So then we would run this command. I have done some labs where I've been able to do this, but this lab isn't going to get into that. Or at least not in this task, it's not. I don't know if it will later, I don't remember. As this is a reverse shell, you would also run the Metasploit handler module configured accordingly. Once you have transferred the file you have created, you can then run the installer in the command below and receive the reverse shell. So what is the flag for task user 1? We're going to go and grab that out of our notes. Throw that in here. And move on to task 5. Abusing service misconfigurations. Windows services. Windows services are managed by the Service Control Manager, the SCM. The SCM is a process in charge of managing the state of services as needed, checking the current status of any given service, and generally providing a way to configure services. Each service on a Windows machine will have an associated executable, which will run by the SCM whenever a service is started. It is important to note that service executables implement special functions to be able to communicate with the SCM, and therefore not any executable can be started as a service successfully. Each service also specifies the user account under which the service will run. To better understand the structure of a service, let's check the app host service configuration with the scqc command. And we see that we can run this. I'm imagining I want to run this as my user here. Service pasting isn't working for some reason, and that is our output. Does that look the same? Yes, it looks the same. Okay. And continue. Here we can see the associated executable is specified through the binary path name parameter, and the account used to run the service is shown on the service start name parameter. Oh, okay, yep. Services have a discretionary access control list, a DACL, which indicates who has permission to start, stop, pause, query status, query configuration, or reconfigure the service, amongst other privileges. The DACL can be seen from Process Hacker, available on your machine's desktop. Oh. Let's go ahead and minimize. Oh, that's what this is. Okay. All right, just kind of looking through here. So I don't see that exact view. All of the service configurations are stored on the registry under HKLM system current control list. Okay, in the registry editor. So it's showing us an example of that. A subkey exists for every service in the system. Again, we can see the associated executables on the image path value and the account used to start the service on the object name value. If a DACL or DACL has been configured for the service, it will be stored in a subkey called security. As you have guessed by now, only administrators can modify such registry entries by default. And I'm just not seeing Apple service properties. So, oh, okay. So if I go to properties, I get a little bit more about the different processes. So I'd want to go to app host service. But I'm not sure if I need to do this to answer any questions right now. So for now, I'm just going to continue to read. And we'll get there when we get to the questions, I suppose. Insecure permissions on service executable. If the executable associated with a service has weak permissions that allow an attacker to modify or replace it, the attacker can gain the privilege of the service account trivially. To understand how this works, let's look at a vulnerability found on Splinterware system scheduler. To start, we will query the service configuration using SC. Let's go back into our command prompt. And I think we want to run this under this one. To understand how this works, let's system scheduler. Okay. See if I can control V this in. There it goes. Sometimes it's not working, sometimes it is. And is this the same output? It looks like it is. Okay, so that was successful. I'm going to grab this up. I'm not sure if I need this for my notes, but then we can see that the service installed by the vulnerable software runs as SVC user 1, service user 1. And the executable associated with the service is in C program system1 service.exe. Kind of lays it out right here. Was that different? Oh, no, that's it. Okay, same thing. We see that the service installed by the vulnerable software runs as service 1. Yep, that'll... Oh, there we go. Okay. And here we have something interesting. The everyone group has modified permission M on the service executable. This means we can simply override it with any payload of our preference, and the service will execute with the privilege of the configured user account. Let's generate an exe service payload using MSF Venom and serve it through Python web server. Okay, so now we want to run this. We're going to create payload, start a Python server, and then deliver that to this machine. Okay, cool. I believe I can exit out of this. And for this, we're going to do update our notes section. Always good to have notes to go back to review. So that's our payload. And then deliver. Server. I like to review my notes later. So let's go ahead and throw this in. I'm going to run that. And go grab the next thing that we're going to run here. Throw that into my notes. No platform was selected. Oh, I messed up on doing this. Okay, so I need to specify my IP, which is above right here. Apologize, I forgot to do this. Okay, I think the rest is okay. Let's read what our errors were. No platform was selected. Choosing MSF module platform. What were our notes here? Using MSF Venom and serve it through Python. Okay, this should be reverse TCP, listening host will be my IP. I set up the port, TAC F. I'm going to try to run this again and see if I get another error. Okay, I should have that now. Right here. So I have the file, svc.exe. Okay. Now we need to serve this up, but I need to... So our next step is running Python 3, getting the web server spawned. For the web server, do I want to specify anything? Oh, it defaults to port 8000. Okay, that's good. It should be fine. Port 8000. Now we want to... We can then pull the payload from PowerShell using wget. I just need to add in my IP. Let's do that right into our notes. Oof. Okay. That should be good. And we could just fix this command right here with the IP address from my target machine. Remember again, ton 0. Copy it. Attacker IP. We want to delete it from here. Throw it in. Copy this. Back over to our box. Now I want to open up PowerShell. Run PowerShell, and I think I could just Control V that in. Oh, that might be a problem. Oh, there it is. We got the file. Okay, it is on the target. Once the payload is in the Windows server, we can proceed to replace the service executable with our payload. Since we need another user to execute our payload, we'll want to grant full permissions to the everyone group as well. So let's see what we're doing here. Oh, I'm gonna need to start a netcat reverse listener in a moment, but let's see. So if we cd, we're back in command prompt to do this. What user am I using? Move. So I believe I could use this user from earlier, this one. Let's try it. It's not copying and pasting. Yes, I could write this out, but it might take longer. And since I'm recording, I want to try to do this quick. Is that going to work? Because that's not the name of... So we're going to move wservice.exe. Okay. One file has moved. Next, we're going to move this. Copy it and paste it. Enter, one file moved. And now we want to grant the permission for everyone. Copy it. Successfully processed. Okay. We start a reverse shell listener. Just grab that. We no longer need our Python server, so we'll run our netcat listener. And finally, restart the service. While in a normal scenario, you would likely have to wait for a service restart, you have been assigned privileges to restart the service yourself to save you some time. Use the following commands from a Cmd.exe prompt. So I'll grab this and throw this in. Throw this in here. And then we want to grab the next command and start the service. The first one stopped it. Now we're starting it. Let's see, start. And does that give us our shell? PowerShell has sc as an alias to set content. Therefore, you need to use sc.exe in order to control services with PowerShell in this way. As a result, you'll get a reverse shell with svc user1 privileges. Let's check. There we go. And who am I? As you can see, we are that user. Go to service user 1's desktop to retrieve a flag. Don't forget to input the flag at the end of this task. Absolutely. So let's do that now. cd users. Let's see. user 1. There. Excellent. So we're able to get the flag. I'm just going to grab this whole thing and throw it into my notes to keep them. Okay. Good notes for later. I should grab this as well. I think at least up to here. And typically, yeah, I'm just going to go up and throw it above, because I did do it here. And I'll clean up my notes after the video. Okay, get back to the task at hand. Unquoted service paths. When we can't directly write into service executables as before, there might still be a chance to force a service into running arbitrary executables by using a rather obscure feature. When working with Windows services, a very particular behavior occurs when the service is configured to point to an unquoted executable. By unquoted, we mean that the path of the associated executable isn't properly quoted to account for spaces on the command. As an example, let's look at the difference between two services. These services are used as examples only and might not be available in your machine. So that's a key point. We might not see this. The first service will use a proper quotation to the SCM so that the SCM knows without a doubt that it has to execute the binary file pointed by C program files, real VNC, VNC server, VNC server.exe, followed by the given parameters. And we get an example here. So can I run this? Let's just check. Oh, it did run. Oh, the specified service does not exist as an installed service. Okay. What did we get? Did we get any of this? Disk scheduler. Okay. So we get an example here. We could see this. Auto start ignore. Okay. When the SCM tries to execute the associated binary, a problem arises. Since there are spaces on the name of the disk sorter enterprise folder, the command becomes ambiguous and the SCM doesn't know which of the following you are trying to execute. And we get the commands and the arguments in here. This has to do with how the command prompt parses a command. Usually when you send a command, spaces are used as an argument separator unless they are part of a quoted string. This means the right interpretation of the unquoted command would be to execute this path with disk.exe and take the rest as arguments. Instead of failing as it probably should, SCM tries to help the user and starts searching for each of the binaries in the order shown in the table. Okay, I see. First, search for this disk.exe. If it exists, the service will run this executable. If the latter doesn't exist, it will then search for disksorter.exe. If that exists, the service will then run that executable. And if the latter doesn't exist, it will then search for disk sorter enterprise bin disk srs.exe. The option is expected to succeed and will typically be run in a default installation. Okay, so it iterates through these. From this behavior, the problem becomes evident. If an attacker creates any of the executables that are searched for before the expected service executable they can force the service to run an arbitrary executable. While this sounds trivial, most of the service executables will be installed under C program files or C program files x86 by default, which isn't writable by unprivileged users. This prevents any vulnerable service from being exploited. There are exceptions to this rule. Some installers change the permissions of the installed folder, making the services vulnerable. An administrator might decide to install the service binaries in a non-default path. If such a path is world writable, the vulnerability can be exploited. In our case, the administrator installed the disk sorted binaries under C programs. By default, this inherits the permission of the C directory, which allows any user to create files and folders in it. We can check this using icacls, or can I run this? Yeah, let's run it. And we get the same output. The built-in users group has AD and WD privileges, allowing the user to create subdirectories and files respectively. The process of creating an exe service payload with MSFenum and transferring it to the target host is the same as before, so feel free to create the following payload and upload it to the server as before. We will also start a listener to receive the reverse shell when it gets executed. So it looks like we are going to do this again. Run it on port 446, service 2. All right, let's grab this command. We are going to drop out of here. We've already grabbed this password, put it into our notes, so we can easily come back, put that in when it asks for that flag. Let's control C. We are going to create a second payload and edit it here before throwing it into our command prompt or our command line. Because once again, I need to throw in my VPN IP address. Let's drop back. Where is that? Right here. Throw that in there. Looks good. I'm going to grab this, copy it. Oh, I think I need to upload it first, but let's go ahead and create the payload. So it should be svc2.exe. We'll list out the contents. I'm in caps lock. That's not going to work. We can see the files there. Start my netcat listener, but we still need to get the payload over. Once the payload is in the server, so we're going to have to do... Is this going to have us add it? We're going to walk through the motions here. I'm going to start the netcat listener. And then we need to deliver the payload again, which we did above. Did I save it? So we're not going to run this. We're going to run, I'll just type it out, Python 3 HTTP server I need to go back over. We're going to run this wget command again. Copy. Need to deliver payload. And we just need to change the name of this to service 2, I think it was. Yeah. Okay. Copy this. Oh, we need to output it to. I need to change that as well. Make sure that looks good. Throw in. That's so I know I stopped. Copy it. Jump over. PowerShell. We're going to run it. Looks like it grabbed it. There. Okay, it's right here. So we did get it onto the server. Okay. I throw in. Okay, good. So everything's looking good. Now we need to move it. Jump back into our box, back into our command prompt. We're going to run that from here. One file moved. And we make it executable. Throw this command in. That's everyone that is successfully processed. And here we go. We're going to start. Once the service gets restarted, your payload should execute. So let's go ahead and run this through. All right, start it. And we should see a reverse shell right after we start it. As a result, you get a reverse shell. We did not get the reverse shell. Did I do something wrong? What did I do? Service name. Running. See. Oh, I see what I did. Let's see. Start. Wait, no, I don't. Stop. Start. Four, 6, right? Oh, I didn't run the netcat listener. All right, so I goofed. That's okay though. All we have to do to recover is stop the service. And then start the service again. Let's see if that worked. All right, it did. Who am I? And we are service user 2. I think this will have us go to the desktop, right? Go to the desktop, grab the flag. Don't forget to input it. So we're going to want to save this. All right. We do not want to dir system32. It will run for a long time. And then I'm going to cd into user. SV user 2 desktop. Hopefully I got that right. No, I didn't. CD user. Oh, I'm doing it wrong. CD users. Flag.txt. All right. So we got it. I don't want to copy all of that. Throw that in. And we've got our second flag. And we can move on to insecure service permissions. You might still have a slight chance of taking advantage of a service if the service's executable DACL is well configured and the service's binary path is rightly quoted. And I'm sorry if you don't call that DACL, and I keep saying that. I don't know the proper term, DACL, DACL. It just sounds natural to me, but I digress. Should the service DACL, not the service's executable DACL, allow you to modify the configuration of a service, you will be able to reconfigure the service. This will allow you to point to any executable you need and run it with an account you prefer, including system itself. To check for a service DACL from the command line, you can use access check from the sys internal suite. For your convenience, a copy is installed in ctools. The command to check for THM service DACL is. So can I, it looks like I can just run this from command prompt. Oh, I want to navigate to it though. So those are my notes. Let's go back into our box and cd into tools. And access check. Oh, did I run it? What did I do? I hit Control V. I'm not sure. I thought I copied it. Let's just copy it now. And run it. And we get our sys internals software license terms agree. Okay, and it output some information for us. So it did run. Not sure if I need to copy any of this into notes if there's going to be a question on it. So let's just keep going, and then it looks like we're going to do another attack. Here we can see that the built-in users group has the service all access permission, which means any user can reconfigure the service. Oh, got it. Okay, so it's setting us up for our next attack. We can see what services we can run, what we have access to. Before changing the service, let's build another exe service reverse shell and start a listener for it on the attacker machine. Okay, let's get our notes ready. We're about to do another attack. Create payload 3. Sure, looks good. Now let's grab our command, our MSF Venom. Go into our notes, throw that in, and we're going to change the IP once again. Now that we have this, I'm going to Control C out. I'm just going to IP A to get my IP address again, make it easy. Grab it. Throw that in for the attacker IP. Using port 447 now. First TCP, executable, service 3. Okay. Back into here. Before we set up the netcat listener, what do we need to do? I'm going to have to deliver this again. We know that. So let's grab this real quick. Deliver payload. I should just make this clear. This is payload 3. Anytime I need to go back into my notes, we're going to do service 3. And let's just make sure that that's what we're doing. Rev service 3. Yes, it is. Let's grab it and create it. Put it in here. It's an executable service. Run it. It should tell us if we have a problem. Let's list out the contents. We can see service 3 here. So that is good. Now we need to grab it. I'm going to go ahead and start my netcat listener. I think it was LVP 4447 this time. Just go ahead and be thorough. Oh, before I set up the listener, I need to, this is where I messed up last time. I need to set the Python server. That's Python 3 Tryhackme. Is that http.server? Oh, I don't see it. But we can go back in our notes and grab that command as well. Did I not copy the notes for that? I didn't copy it for the second time because I was getting myself confused. http.server. Let's throw that in. Deliver payload. So we need both steps to deliver the payload. And then oh no. Just do that for now. I know it's not consistent with my notes, but I'll fix those when I'm not recording because I don't want to delay this too much on you while I try to be a perfectionist. So now I need to go grab it. Let's run the HTTP server. We see that that's running on 8000. We need to go to PowerShell. Although, did I set that up right in my notes? Yes, that should work. There's only one way to find out. Looks like it grabbed it. Should be good. Now we want to go ahead and we will transfer the reverse shell executables to the target machine and store it in the C drive. Okay, it gives us the directory there. Feel free to use wget to transfer your executable and move it to the desired location. Remember to grant permissions to everyone. Oh, we got to move it. And it's not giving us the command to move it. This was the old command, but okay, let's look at this. It tells us store it here. Okay. Set up the listener. Before we set up the listener, we need to move the file. Move destination. Just throw that in. I should have been keeping that in my notes, and I don't think I was. Throw that in. So this was our old move command. I'm going to edit this once I have We want to move it to here. Okay. That looks right. I'm hoping that's right. We'll get a message if it's not. Let's grab it. Go back. And we've been moving it from here. Do I need to be in this directory anymore? I don't think I do. Let's cd back out. And I threw it in, it moved. That Control V just worked really quick. Now we want to do this. Feel free to use wget to transfer. We did that. Remember to grant the permissions to everyone. That's what we're doing next. We're granting permissions for everyone. Processed successfully. So let's copy this. And just throw this into our notes. We'll move to destination and set permissions. Sure. Okay, so we have these examples to work with. And this is why it's good to keep these notes, because you got to go back and do stuff, and it isn't always so thorough, the directions. Now we want to get into stopping the service, starting the service, right? To change the service associate executable account, executable and account, we can use the following command. Mind the spaces after the equal signs when using sc.exe. Let's throw this into here. scconfig. And it looks like that was a success. Throw this into our notes as well. This is kind of out of place now. Oh no, it's not, because we don't need to set up the listener yet. We should. Actually, let's Control C this. Just gonna type it out. nclb4447. Get our listener running, because I'll forget. But I want to capture this as well. And what was it that we did with that command? We were granted permissions to everyone, change the services associated. I'm going to grab this and throw it into my notes so I know for later. Okay. Started the netcat listener. Oof. We're good up to this point. Set up the listener. Oh, we need to start and stop the service. I'll just copy it once I've thrown it in. And we get the output from it. So there we go. Let's stop it. The service has not been started. That failed. Notice we can use any account to run the service. We chose local system. This is the highest privilege account available. To trigger our payload, all that rests is restarting the service. Maybe we just need to run it. Let's try. See if this gives it to us, maybe. Okay, the service is running. We got the reverse shell, so it looks like the stop didn't have to happen. It wasn't running anyway. Who am I? Then we are NT authority system. Go to the admin desktop to retrieve a flag. And now we should be able to input all these flags, which is what we want. So we're going to cd. And then we're going to go into users. Although I think we just want the administrator account. Yep, there's the flag type. Great. So we are able to get all 3 flags. Now we need to input them. Just going to grab this all. I'm not going to grab it all, actually. I lied. Just grab that. Oof. Cut buffer is empty, which, there we go. I wasn't grabbing it correctly. Answer the questions below. Get the flag on SVC user's desktop. Let's go all the way back up to the first flag we got. SVC user 1, grab that flag from our notes. Throw it in and check it. Get the flag on SVC user 2's desktop. Scroll down in our notes. Here's that flag. Copy it. That in and check it. And then the final one, get the flag on the administrator's desktop, which was all the way at the bottom. Copy. Throw that in and check it. All right, so we're done with those tasks. Now we are on to task 6, and I also think that's going to conclude this machine. It looks like we're going to start another one here. And we probably have to stop this one, so I think we're good to close. Pointing at my notes, but I think we can close this. So I'm going to go ahead and exit out of this. And I'm just in an RDP session here, so I'm going to close it and terminate it. I'm going to save my notes really quick. I'm going to exit out of this, Control C, clear that, clear, and we can jump back in to our machine. Abusing dangerous privileges, task 6. Windows privileges. Privileges are rights that an account has to perform specific system-related tasks. These tasks can be as simple as the privilege to shut down the machine up to the privileges to bypass some DACL-based access controls. So I'm going to go ahead and start our machine. And that's going to come up. I'm going to continue to use my RDP session, I believe. But we'll see what this has me do. Each user has a set of assigned privileges that can be checked with the following command: whoami/priv. Complete list of available privileges on Windows systems is available here. From an attacker's standpoint, only those privileges that allow us to escalate in the system are of interest. You can find a comprehensive list of exploitable privileges on the priv2admin GitHub project. I'll probably save this into my favorites later. While we won't take a look at each of them, we will showcase how to abuse some of the most common privileges you can find. cbackup/crestore. The cbackup and crestore privileges allow users to read and write to any file in the system, ignoring any DACL in place. The idea behind this privilege is to allow certain users to perform backups from a system without requiring full administrative privileges. Having this power, an attacker can trivially escalate privileges on the system by using many techniques. The one we will look at consists of copying the SAM and system registry hives to extract the local administrator's password hash. Log into the target machine via RDP using the following credentials. So we get some different credentials that I'm going to input into my FreeRDP in a moment. This account is part of the backup operators group, which by default is granted the cbackup and crestore privileges. We will need to open a command prompt using the Open as Administrator option to use these privileges. We will be asked to input our password again to get an elevated console. Once on the command prompt, we can check our privileges with the following command. Okay, just seeing we get our examples here. To set up the SAM and system hashes, we can use the following commands. Reg save. So we're going to mess with the registry here. Okay, this will create a couple of files with the registry hives content. We can now copy these files to our attacker machine using SMB or any other available method. For SMB, we can use Impacket's SMB server.py to serve a simple SMB server with a network share in the current directory of our tap box. All right, so I wanted to read that a little deeper to just understand what's being required of me here, so I can go ahead and set this up and get prepared. All right, I'm going to hit F11, jump out of my full screen here, go into, let's go back into our notes.txt. I'm going to copy my command here, scroll all the way to the bottom or hit end or control end. Should take me all the way to the bottom. New RDP. Just do that. All right, so we have different credentials for this. We have a different IP address. First, what I want to grab are the credentials. Throw those into my notes. And then the password. I'll grab the IP address in a moment. Got that saved. Grab the IP. All right, let's save that. Oof. Back. Yeah. Notes.txt. Okay, got it right at the bottom here. Next, I'm using Impacket for this. I don't have Impacket on my box, but I want to try to use it in RDP session. So what I'm going to do is I'm going to go grab it. So I have the GitHub here. Let's just jump into here. And I think I can install it from app. Just going to install some prerequisites first. I'm not sure if these are already on Parrot or not. Python 3 dot virtual environment, Python 3 dot pip, I think are all I'm gonna need. Okay, should be good there. I'm gonna sudo git oh, right here. All right, let's just grab Impacket, and I want to put this into opt Impacket. I don't think I have this directory. It might say I need to create it. Let's run it. Okay, looks like that's good. Sudo change ownership. So that I don't have to sudo it. Okay. I should be able to go right into it. All right, I think I'm set up well for this now, and we can continue on. With our task. So restore privileges allows users to read and write to the file of the system, ignoring any DACL in place. User set up the account as part of the backup operators group, which by default is granted. Okay, so we need to go in and do this. My next step is going to be running our command. I believe I have that all right. Let's run it. Get our RDP session going. We're going to want to run this command from command prompt, but we want to run command prompt as administrator. Oh, and I think it said, yeah, we got to put in the password, which is copy master 555. Oh, I can't control paste that in. Okay, so I got to type that out. Copy master 555. And we have an administrative prompt. And that should match our output. Let's go back to minimizing this. Resize our screen. Should be good. Okay, so we just ran this. Looks to match. Once command prompt, we can check our privileges. To back up the SAM and system hashes, we can use the following commands. So we're going to want to run this. Copy it. Operation completed successfully. And now we need to save, rug save. Now we need to run this next one. So to back up the SAM and system hashes. So this must be SAM and system. Oh, the first one was our system. The second one is our SAM hive. Got it. Okay. And maybe I need to start saving these into notes again. Let's nano our notes. Control End takes you all the way to the bottom of your notes. New RDP session. Let's just do, I'm just going to throw these in here. Try to move through this a little bit faster. Okay, this will create a couple of files with the registry Hive's content. We can now copy these files to our attacker machine using an SMB or any other available method. For SMB, we can use Impacket's SMB server.py to start a SMB server with a network share in the current directory of our attack box. I'm not using the attack box though, I'm using my machine, so I'm going to need to set that up. All right, so my next step is setting up Impacket so that I can run commands similar to this on Parrot OS. So what I'm going to do is run Python in a virtual environment. And then I want to list out a Impacket. List out bin. See what we get. And now I want to do source Impacket and activate. Ooh. Let's go back and throw in the /. Now we've got our environment set up. Version. Okay, 3.3. So this is going to be a little bit different. Let's now run pip install pip. And then we're going to do pip install back our requirements .txt. And then pip install. And now let's just make sure. Let's verify it. Python.exe. And it looks like Impacket is good to go. Let's cd into examples. And what does this have us doing? Impacket examples, SMB server.py. Master public share. Okay. Let's do Python. I think I did that right, that pi. And just make sure this works. We get our help menu. Okay, so we can look at secrets.py. Performs various techniques to dump secrets from the remote machine without executing any agent. Okay, it's looking good to me. All right, so now that output, we're gonna go ahead and set up our environment. I'm gonna make a directory. And I'm gonna put it in home. I'm gonna name it THM Hives. And then I'm going to sudo opt Impacket. In Python and opt Impacket examples SMB serve. Did I do that wrong? Examples SMB server.py share. Invert. And we're going to do SMB to support. Looks like it's running. I think it's running. I'm going to try to move forward here with, let's see if we can copy. I just need to add in my IP when I throw this in, which I might need to open another window. Control Shift O. Let's throw this in. Grab my IP. And see if we can get this to work. So I'm not sure if that is connected or not. Hacker IP. And it should be in share. THM backup. Sam Hive. Let's try this. You can't access this shared folder because your organization security policies block. We'll do it if I do public. Can't access. It doesn't look like that's working. All right, so I think I need to add onto this. Control C. I think I need to add my username and password from the lab. So let's grab the username, grab the password, which I probably had it saved over here. Could have just grabbed it from there. Let's throw that in and see if we can get it to work. I think username is how to do this. Username, backup. And password should be copy master 555. Let's try running this again. Again, I'm going to run it from the share, maybe. One file copied. So it looks like that worked. And now we should be able to copy this other file as well. So I'm going to grab it. And I need to modify that just a bit. Throw it in, grab our IP. And I'm going to do share. should work. Let's go ahead and run that. Taking a little bit. See users, teach and backup SAM system.hive. Oh, I'm missing a messed up. That messed up. Okay, let's copy that in right. There we go, one file copied. So it looks like that worked. Okay, once we do that, add and use Impacket to retrieve the user password hashes. Okay. All right, so I'm gonna go back to my terminal. I'm just gonna keep that open in case I still need it. And let's run. So we've got secret dumps.py. We're gonna need to run on the SAM and the system hive files. First, I'm gonna go ahead and get into a virtual environment with Python in here. So source, I'm gonna do Impacket. And we'll activate. Okay. Next, I think I need to, let's see. I'm gonna change ownership of the sam.hive and system.hive file. So we're gonna change this to Robert, and that should be in my home. Robert, HM, hives, sam.hive. And then also for home, Robert, THM, system.hive. Okay. Now I want to run secrets dump.py. I'm going to do Python secrets dump.py for SAM. And then we need to list out where that is, which it's in home, Robert THM hives, and then we need to say sam.hive. We also want to do system, and that is in home, Robert HM, and that is system.py, and run that local. I just don't like how the screen looked there. That should do it. And now we have our hashes cleaning up. I'm going to save these. We'll just save this into our notes. Okay, so admin guest, default account, a utility account, the backup, and THM take ownership. All right, so let's see what we need to do next. Packet Python 3. We can finally use administrator's hash to perform a pass the hash attack and gain access to the target machine with system privileges. So we're going to run ps exec. Okay, so that's what we need to do next. We need to run Python PS exec. Right here. Okay, I see it. I'm going to run that on this administrator account with the hash. So I'm going to copy this. Copy. Make sure I spelled that right. And we want to put in, all right, so I'm going to throw in the hash. I'm just going to space this here. Oof. That didn't come out like I wanted. But I need to go grab the IP address for the machine. I probably could have just grabbed it from my notes, actually. We got it right here. Check out the whole thing. The IP. Then we want hashes. Space, we've got the hash. What else do we need to do? Oh wait, do I do the... I think that's it. I've got the admin and the IP. Got the hash. I think that's all I gotta do. Okay, let's see. Python. Looks like I might have an extra space here. No. Okay, I'm gonna run it. It looks like we got in. All right, so take ownership. The take ownership privilege allows a user to take ownership of any object on the system, including files and registry keys, opening up many possibilities for an attacker to elevate privileges. As we could, for example, search for a service running a system, take ownership of the service executable. For this task, we will be taking a different route, however. So I think we're jumping to something totally different. All right, hold on. Get the administrator. Okay, let's just see if we can grab the flag. Dir. And we did get the flag. So I think it's jumping to a whole different thing. Let's just grab this out. Throw this into our notes. And look at what these other tasks are, because we could finish 6 with that. And then I can continue and do the other ones, maybe. Let's look at these. What else do we got to do? Impersonate. Okay, I'm going to go ahead and answer the question now. And come back to the other ones. Let's copy. Make sure it works. Okay, so we've finished task 6, some of it. We went ahead, we grabbed the password with the very first task. Now there's these additional tasks that we can run and use different users. And this also allowed me to set up Impacket on Parrot, which I'm going to use for some other Windows systems in the future. So that's great. Now, let's look at this. The C take ownership privilege allows a user to take ownership of any object on the system, including files and registry keys, opening up many possibilities for an attacker to elevate privileges so we could, for example, search for service running a system and take ownership of the service's executable. For this task, we will be taking a different route, however. Log into the target machine via RDP using the following credentials. So in this one, I'm going to need to set up my RDP for a totally different session. I'm going to kill it. I'm going to exit out of this. And get out of my environment. I don't know that I need Python. It looks like something's not working. Having an issue with my box. So I'm going to Control Shift. I think it's W gets rid of this window. I'm going to end that session. Exit. And CD back. Clear out of here. Let's update our notes now that we've got that flag. We're going to start a new RDP session. Copy it. That to the notes. And just going to play this for now. Oops. Okay. Because I might take myself a quick break before I do the next one. So I'll come back. In fact, I might even terminate the machine, restart it, and start into the next one. Okay, I've gone ahead and made the adjustments for FreeRDP. I've added the new IP. Here we have the username that matches and the new password. I've already connected to the RDP session just to get started so we can continue. The C take ownership or SE take ownership privilege allows a user to take ownership of any object on the system, including files and registry keys, opening up many possibilities for an attacker to elevate privileges, as we could, for example, search for a service running a system and take ownership of the service's executable. For this task, we will be taking a different route, however. Log into the target machine via RDP, which we have already done. To get the C take ownership privilege or SE take ownership privilege, we need to open the command prompt using open as administrator option. Let's go ahead and do that. Just right click on it, run it as the administrator. Is mine 2022. Let's make sure we did that right. Oh no, it went away. I can't see. Let's just say yes. Okay, we have our command prompt. Once on the command prompt, we can check our privilege with the following command. whoamipriv /priv. And we can see our privileges. So take ownership disabled. Bypass is enabled. Increase processing disabled. Okay. Set match. That does match. We'll abuse utilman.exe to escalate privileges this time. Utilman is a built-in Windows application used to provide ease of access options during the lock screen. Since utilman is run with system privileges, we will effectively gain system privileges if we replace the original binary for any payload we like, as we can take ownership of any file. To replace utilman, we will start by taking ownership of it and with the following command. So we're just going to run this, take own, /F, see Windows. Okay, we'll run that. It's successful. Notice that being the owner of the file doesn't necessarily mean that you have privileges over it, but being the owner, you can assign yourself any privileges you need. To give your user full permission over utilman.exe, you can use the following command. So we're going to run this now, and we'll take a look at it once I copy paste it. iCalcs or ICACLS, then we're going to take command of the executable, and we're going to grant ownership. Okay, let's go ahead and execute that. And it is successfully processed. After this, we will replace utilman.exe with a copy of command.exe. Oh, okay, so I see where this is going. This way, I think we can just spawn ourselves a command shell. It's command copy. All right, so we're going to replace it. We're going to say yes to overwrite. And one file copied. To trigger utilman, we will lock our screen from the start button. And finally proceed to click on the ease of access button, which runs utilman.exe with system privileges. Since we replaced it with Cmd.exe copy, we will get a command prompt with system privileges. So we need to lock the screen. And then we need to run this, and we get our command prompt. We can do who am I, priv, and see the privileges, how they've changed. Okay, and I think now with this, we would be able to cd. Oh, we want to go into users. System cannot find. Didn't we want to cd into the administrator desktop? And we would have been able to type out the flag. So that would have been the other way that we got the same flag used to answer this challenge. Let's make sure. Yep. Okay, so it looks like there's one more to do. SE impersonate, SE assign primary token. These privileges allow a process to impersonate other users and act on their behalf. Impersonation usually consists of being able to spawn a process or thread under the security context of another user. Impersonation is easily understood when you think about how an FTP server works. The FTP server must restrict users to only access the files they should be allowed to see. Let's assume we have an FTP service running with user FTP. Without impersonation, if user Ann logs into the FTP server and tries to access her files, the FTP service would try to access them with its access token rather than Ann's. There are several reasons why using FTP's tokens is not the best idea. For the files to be served correctly, they would need to be accessible to the FTP user. In the example above, the FTP service would be able to access Ann's files, but not Bill's files, as the DACL or DACL in Bill's files doesn't allow user FTP. This adds complexity as we must manually configure specific permissions for each served file directory. For the operating system, all files are accessed by user FTP, independent of which user is correctly logged into the FTP service. This makes it impossible to delegate the authorization to the operating system, therefore the FTP service must implement it. If the FTP service were compromised at some point, the attacker would immediately gain access to all of the folders to which the FTP user has access. If, on the other hand, the FTP service user has the SE impersonate or SE assign primary token privilege, all of this is simplified a bit, as the FTP service can temporarily grab the access token of the user logging in and use it to perform any task on their behalf. Now, if user Ann logs into the FTP service, and given that the FTP user has impersonation privileges, it can borrow Ann's token, Ann's access token, and use it to access her files. This way the files don't need to provide access to use FTP in any way, and the operating system handles authorization. Since FTP service is impersonating an, it won't be able to access Jude's or Bill's files during that session. As attackers, if we manage to take control of a process with SC impersonate or SC assign primary token privilege, we can impersonate any user connecting and authenticating to that process. In Windows systems, you will find that local service and network service accounts already have such privileges. Since these accounts are used to spawn services using restricted accounts, it makes sense to allow them to impersonate connecting users if the service needs. Internet Information Service, or IIS, will also create a similar default account called its app pool or default app pool for web applications. I'm sorry, it was IIS app pool or default app pool for web applications. To elevate privileges using such accounts, an attacker needs the following. 1. To spawn a process so that users can connect and authenticate to it for impersonation to occur, and 2. Find a way to force privileged users to reconnect or to connect and authenticate to the spawned malicious process. We will use rogue WinRM exploit to accomplish both conditions. Let's start by assuming we have already compromised a website running on IIS, and that we have planted a web shell on the following address. So can we go to this in our machine? I don't remember what the password was. What's the password? The world is mine 2022. Oh, I did that wrong. Okay, back in. Let's try to go to that IP address. Put that in. Oh yeah, we get a program. Okay. We can use the web shell to check for the assigned privileges of the compromised account and confirm we hold both privileges of interest for this task. Okay. Let's run that. Oh, there we go. Okay. To use rogue WinRM, we first need to upload the exploit to the target machine. For your convenience, this has already been done, and you can find the exploit in the tools folder. Let's see if that's in there. I could navigate with that, but it says it's in the C drive. Tools folder. Oh, here we go. Okay. The rogue WinRM exploit is possible because whenever a user, including unprivileged users, starts the bits service in Windows, it automatically creates a connection to port 5985 using system privileges. Port 5985 is typically used for the WinRM service, which is simply a port that exposes a PowerShell console to be used remotely through the network. Think of it like SSH, but using PowerShell. If for some reason the WinRM service isn't running on the victim server, an attacker can start a fake WinRM service on port 5985 and catch the authentication attempt made by the bits service when starting. If the attacker has SC impersonate privileges, he can execute any command on behalf of the connecting user, which is system. Before running the exploit, we'll start a netcat listener to receive a reverse shell on our attacker machine. So how is this going to work if I didn't create this tool? Rogue WinRM, let's look at the command here, and then use our web shell to trigger the rogue WinRM exploit using the following command. Oh, so we send it back to our netcat listener. So this should work just fine. Let's go ahead and start a netcat listener. Oh, that's not it. I guess we just need the port, really. we'll fire up our listener. And then we want to run this on this system. I'm going to go ahead and open up a text document so I can edit this. And we want to connect back to our IP. Again, looking at ton 0. And port 4442. Okay, so it looks like we just throw this in the program and run it, right? Let's give it a shot. Throw it in, hit run. And boom, we've got ourselves a shell. So we are NT Authority System. And we should be able to navigate now over to the administrator folder again, or the desktop, and grab that flag for the 3rd time. But let's finish reading. Note the exploit may take up to 2 minutes to work. It actually worked very fast for us. So your browser may appear as unresponsive for a bit. This happens if you run the exploit multiple times, as it has to wait for the bit service to stop before starting again. The bit service will stop automatically after 2 minutes of starting. The TACP parameter specifies the executable to be run by the exploit, which is nc64.exe. In this case, the TAC-A parameter is used to pass arguments to the executable. Since we want nc64 to establish a reverse shell against our attacker machine, the arguments to pass to netcat will be TAC-E Cmd.exe, the attacker IP, port 4442, which we've established. If all was correctly set up, you should expect a shell with system privileges, and we do have that. Using any of the 3 methods discussed in this task, gain access to the administrator's desktop and collect the flag. Don't forget to input that flag at the end of the task. Well, let's just make sure that we can do that. It's users administrator desktop. And then we just cat flag. I think I have to do type. And there we go. We have it for the 3rd time. So any of those will work. I have the other ones up in my notes. And you just put it in. Okay, moving on to task 7, abusing vulnerable software. And this task looks like it has its own machine to spawn, so I'm going to go ahead and disconnect. We're going to exit. Oh, I think I just Control-C should get out. Let's clear up our terminal. We'll just cat out our notes so we have them. And we need to terminate the machine. That close. Reopen this. Okay. All right, make sure to click the Start Machine button before you continue, which will deploy the target machine in split view. If you prefer connecting with an RDP, that is what we are going to do as we've been doing it. So I'll start the machine, it's gonna open up, but we're gonna exit right out of split view. And I'll grab the IP soon. Let's get through the reading first. Unpatched software. Software installed on the target system can present various privilege escalation opportunities. As with drivers, organizations and users may not update them as often as they update the operating system. You can use the WMIC tool to list software installed on the target system and its versions. The command below will dump information it can gather on installed software. It might take around a minute to finish. So we're definitely going to run this, but our machine's still coming up, so we're going to give it some time, continue reading. Remember that the WMIC product command may not return all installed programs. Depending on how some of the programs were installed, they might not get listed here. It is always worth checking desktop shortcuts, available services, or generally any trace that indicates the existence of additional software that might be vulnerable. Once we have gathered product version information, we can always search for existing exploits on the installed software online on sites like ExploitDB, PacketStorm, or plain old Google, amongst many others. Using WMIC and Google, can you find a known vulnerability on any installed products? Then we have this case study. So let's go check. All right, we've got our IP now. We need to go back into our notes. I'm going to hit Control-Shift-N to get to the bottom. And with the IP, oh, we got it right here. So it looks like it's the old login. I'm just going to go actually Control-Home. Grab this one, copy it. Control-Shift-End. Let's do new RDP. I don't need to be fancy with this anymore. Let's throw it in. I'll clean up my notes later. And I need the IP address. Grab it. Throw that in. Save it. Cat notes. Really just want the end. Grab this, copy it, throw it in. And we'll connect to our RDP session. Okay. Moving on to our case study here. All right, case study Druva in Sync 6.6.3. The target server is running Druva in Sync 6.6.3, which is vulnerable to privilege escalation as reported by Mateo Malvica. I hope I'm saying that right. Apologize if I'm not. The vulnerability results from a bad patch applied over another vulnerability reported initially for version 6.5.0 by Chris Line. The software is vulnerable because it runs an RPC remote procedure call server on port 6064 with system privileges accessible from localhost only. If you are familiar with RPC, it is simply a mechanism that allows a given process to expose functions, called procedures in RPC lingo, over the network so that other machines can call them remotely. In the case of Druva in Sync, one of the procedures exposed, specifically procedure number 5 on port 6064, allowed anyone to request the execution of any command. Since the RPC server runs as system, any command gets executed with system privileges. The original vulnerability reported on version 6.5.0 and prior allowed any commands to be run without restrictions. The original idea behind providing such functionality was to remotely execute some specific binaries provided with in sync rather than any command. Still, no check was made to make sure of that. A patch was issued where they decided to check that the executed command started with the string C programs Druva in Sync 4, where the allowed binaries were supposed to be. But then this proved insufficient since you could simply make a patch reversal attack to bypass this kind of control. Suppose that you want to execute C program system32 Cmd.exe, which is not an allowed path. You could simply ask for the server to run C programs Druva in Sync and to do patch traversal, that's what this is, for Windows system32 command.exe, and that would bypass the check successfully. To put together a working exploit, we need to understand how to talk to port 6064. Luckily for us, the protocol in use is straightforward, and the packets to be sent are depicted in the following diagram. The first packet is simply a hello packet that contains a fixed string. The second packet indicates we want to execute procedure number 5, as this is a vulnerable procedure that will execute any command for us. The last 2 packets are used to send the length of the command and the command string to be executed respectively. Initially published by Matteo Malvica here, so it's got a link to it, the following exploit can be used in your target machine to elevate privileges and retrieve the task's flag. For your convenience, here is the original exploit code. So I think I could just grab this and run it. You can pop a PowerShell console and paste that exploit directly to execute it. The exploit is also available in the target's machine. Oh, so it's actually on here already. So let's go ahead and resize this. And it says it's in C drive tools. Let's go look. Yeah, there it is right there. Okay. Note that the exploit's default payload specified the CMD variable will create user named pwned in the system, but won't assign him administrator privileges. So we will probably want to change the payload for something more useful. For this room, we will change the payload to run the following command. This will create user pwned with a password, simple pass 123, and add it to the administrator group. If the exploit was successful, you should be able to run the following command to verify that the user pwned exists and is part of the administrator's group. Okay. And then as a last step, run the command prompt as administrator. Okay, when prompted for credentials, use the pwned account. From the new command prompt, you can retrieve the flag of the administrator following the command type. Oh, okay, so it even gives us the command to push that out. Let's open this up in Notepad. And we could see the exploit code. Net user pwned add. Oh no, I dropped my let's log back in. Dropped my session there. And do I need to actually change this net user pwned simple pass? Okay, so we need to grab this and we need to throw that into here. Is that right? Net user password. What was it before? Well, maybe I need to keep it in the quotes though. I'm going to Control A to select it all, Control C to copy it, and then it says to go to PowerShell and run it. And I'll hit enter. And I got a 200 back. I'm assuming that worked. Now I should be able to go back to PowerShell, run it as administrator, I think, is what we're doing here. And we get more choices. We want this one. And we want to put in that password, which is simple pass. 123. And now we're in PowerShell. And we've now elevated to this user. So I should be able to run this command and grab the flag. It's really nice that they give it to us, and I could just copy paste it. And there we go. So I'm going to copy that. I'm going to throw it into my notes as well. And now I just need to grab that and answer the question, copy. And we're on to task 8, tools of the trade. Several scripts exist to conduct system enumeration in similar ways to the ones seen in the previous task. I'm going to go ahead and actually make this full screen. These tools can shorten the enumeration process time and uncover different potential privilege escalation vectors. However, please remember that automated tools can sometimes miss privilege escalation. Below are a few tools commonly used to identify privilege escalation vectors. Feel free to run them against any of the machines in this room and see if the results match the discussed attack vectors. And we've got WinPeas. WinPeas is a script developed to enumerate the target system to uncover privilege escalation paths. You can find more information about WinPeas and download either the precompiled executable or a .bat script. WinPeas will run commands similar to the ones listed in the previous task and print their output. The output from WinPeas can be lengthy and sometimes difficult to read. That is why it would be a good practice to always redirect the output of a file as shown below. Demonstrates it, and then WinPeas can be downloaded from here. Next we have PrevestCheck. PrevestCheck is a PowerShell script that searches common privilege escalation on the target system. It provides an alternative to WinPeas without requiring the execution of a binary file. PrevestCheck can be downloaded here. Reminder to run PrevestCheck on the target system, you may need to bypass the execution policy restrictions. To achieve this, you can use the set execution policy commandlet as shown below. And we've got how to do that here. And finally, we've got WESNG, Windows Exploit Suggester, Next Generation. Some exploit suggestion scripts like WinPeas will require you to upload them to the target system and run them there. This may cause antivirus software to detect and delete them. To avoid making unnecessary noise that can attract attention, you may prefer to use WESNG, which will run on your attacking machine, Kali or Tryhackme Attack Box, or in my case, Parrot OS. WESNG is a Python script that can be found and downloaded here. Once installed, and before using it, type the wes.py tech update command to update the database. The script will refer to the database it creates to check for missing patches that can result in a vulnerability you can use to elevate your privileges on the target system. To use the script, you will need to run the systeminfo command on the target system. Do not forget to direct the output to a txt file. You will need to move to your attacking machine. Once this is done, wes.py can be run as follows. And then finally, we've got Metasploit. You already have Meterpreter shell on the target system. You can use the multi-recon local exploit suggester module to list vulnerabilities that may affect the target system and allow you to elevate your privileges on the target system. Answer the question below. Click continue reading, so it's just a read check. And task 9 is our conclusion. In this room, we have introduced several privilege escalation techniques available in Windows systems. These techniques should provide you with a solid background on the most common paths attackers can take to elevate privileges on a system. Should you be interested in learning about additional techniques, the following resources are available. And then we've got all of these, which I'm going to bookmark these into my Parrot OS. And then we have a read check, and that's going to finish off the room. All right, so this did turn out to be a long one, and I hope you enjoyed the video. I know for me personally, I learned a lot as I went through it again. And I'll just continue through these. Close. So I hope you enjoyed. Thank you for watching. Take care.